Hey everyone, can I have your attention? First of all, I want to welcome everyone to our second edition of Oasis Rendez-Vous. There's food and drinks in the back, swag at the entrance, and we're going to start off with the first panel of the day. Harry, just to join us on stage.
Thank you so much for being here. I just probably could you maybe, if you want to continue the conversation, go on the terrace, or if you want to continue listening to the talks, just have a seat. I think it's going to be very hard to understand anything otherwise. It's quite noisy.
Just be loud. so hi everyone, from Oasis obviously, hopefully you're going to speak about Oasis Sapphire, which is actually Is it just confidentiality that there's I think there's a lot more to it, like is the confidently the next generation of media products. So that's why I'd like to start with the context. So to give you so overall there's a big thing at the moment because much of the infrastructure that we're relying on depends on trust. It's not necessarily a long-way process to remove or reduce trust, because trust is simple and trust is often difficult. Secure enclaves are a big part of that movement. We rely on secure enclaves every single day without even thinking about it. So we have them on our phones, in our payment cards, in our authentication devices, and there's probably billions of devices at the moment that use secure enclaves. There might even be more secure enclaves than there are people on the planet. And if there aren't that many yet, there are going to be very, very soon. So let's start off with what is a confidential EVM? Well, it's not a transparent EVM. So think of Ethereum, Polygon, Arbitrum. You can classify them generically as like transparent chains. So with a transparent EVM, all the cool data is public. It's not encrypted. Even if you try to encrypt the cool data, because you have to store the encryption key in the contract, and everybody can see the encryption key, there's no real point of encrypting it. So a transparent contract could decrypt that data, and it could perform operations on that. But if you wanted to perform encryptions on encrypted data, you'd have to go with something like a fully homomorphic encryption, which at the moment is very, very slow and expensive, and it's still like an active research field to make that practical. And with a transparent EVM, everyone can run the same computations, get the same results, so the execution is verifiable and deterministic. But yeah, it's not confidential, it's not private or encrypted, and if you want any of the private properties like privacy on a transparent chain, it's going to cost a lot of gas, it gets very complicated very quickly, and you often run into some really, really gnarly limitations. So if we wanted to make like an ideal confidential EVM chain, it would be cheap, it would be simple, and you'd have the same freedom that you have with Solidity. So you can get, you want end-to-end encryption between the DApp and the browser and the smart contract, and you wouldn't really have to think about privacy or confidentiality, just like deploy your Solidity applications like you normally do. So the question is, how could we have a confidential chain where all the data is encrypted, and how would we have all of those like synchronized with each other without all the private data leaking everywhere? So our confidential EVM implementation was Oasis Sapphire. It's in production and it's been in there for about a year now. So I'll get very quickly into some details of how it works. So maybe you're an expert in Intel SGX, and Intel SGX is what enables the confidentiality and verifiability. Forgive me if I'm fudging some of these details, but keep it brief. So the contract's running inside a secure enclave, and that's our trusted execution environment. The enclave has an encryption key which rotates about once an hour because of secrecy. And the current key is only shared with the compute nodes who can prove via a cryptographic attestation that they're running the most up-to-date Sapphire software. And the attestation can only come from up-to-date Intel hardware. There's a cryptographically verifiable chain of signatures that ultimately comes down to a unique certificate and tamper-proof key pair that's embedded in the processor. And with Oasis, we also have a compartmentalized key manager. So that's it runs in a secure enclave, but in a different set of nodes. And we've been very careful that with our confidential EVM, none of the individual compute nodes have a master. So they're given a limited subset of keys to decrypt only the data that they need to operate on a case-by-case basis. And they're only given that limited set of keys if their attestations are still valid and up to date. So because execution happens in secure enclave with encrypted memory, that means the node operators can't see what's going on. They can't see the runtime state, they can't see the contract, the encrypted contract storage, and they can't see the core data is passed through their contract. And of course, when you interact with it, because you're encrypting the transactions and queries, it's implicitly verifying that you're talking to the remote. So if you send an encrypted query to the contract, you know that it's really executing that, and it's really giving you a result based on the live data that it has. So for you and the network, you can trust and verify the consensus to the Sapphire nodes, and they all compute the same results on the same data, and they all have the same internal state, and these nodes can communicate with each other. But we can't see the data inside them. We just trust the process that it is executed correctly. And that's a very brief overview of that. So why like transparency, privacy, confidentiality? And in the real world, a lot of the business use cases come down to this area where you could have transparency, or you could have privacy, but in the reality, we need to be able to selectively choose what is private and what is transparent. Otherwise, you get the worst with one world or the other. So most of the world lives in the middle. You also have the address, the stamp, and the front end where you know who's delivering to, and you can verify them with payments and the envelope. But you don't want the data inside the envelope to be physical forever. And this is just how the real world works. So we're trying to get people the ability to have selective disclosure, to choose what is public and to choose what to be private. But by default, everything is private to explicitly disclose what is public. And if we look at like the current state of the art, how is this different from what we envisage like the confidential EVFP? You've got single purpose privacy systems, general purpose, verified, then you've even got confidential computation, like ZKVM, where you have computation from encryption. And those are different from trusted execution. For the single purpose systems, what we use data transaction privacy or communication system encryption, it's like narrow, single WhatsApp, and that's like transactional privacy, single purpose. Then you have things like audio or Mina or ZKVM, there's zero knowledge virtual machines. With these ZKVMs, there's two things. You can either have like confidentiality, where you prove that you compute something with some private data that you have that nobody else knows, or you can use it for the verifiable computation. So you can compute a lot of stuff and with a succinct, constant size proof that you computed a lot of information. With the constant size proofs and the verifiable computation, it's not necessarily privacy that we care about. It's constant, easy, quick verification. But these are, if you start to look at real world use cases, neither of these are particular ideas. So you go and take a text, for example, and you're lots of different people who are interacting with each other. They want to keep all of their own information private for each other. If you wanted to make a text with an NPC system, it would be very complicated, very quickly. Because you have to have somebody out there that holds all of the information about the author in private that nobody can see when they interact with it. And you can't really do this with a ZK-based system because it doesn't have the concept of its own secrets. You can only have secrets that you have while you prove, and somebody has to prove a ZK-based system. So if you want to make it active, it doesn't really work in practice. And you can do that with a combination of EthCC and programmable encryption, but it's very slow, very tedious. As soon as you have to start communicating with other nodes to keep this information private. And in reality, this is millions and millions of cases of exponential computation explosion. And what you're really trying to do is where's the sweet spot? So with trust execution, you get to execute contracts in real time, basically at your speed. You don't have to specifically design your application to be confidential. So you don't have to think of everything from the get-go. You don't have to design it in. You can let the ecosystem evolve. Contracts can talk to each other. You have the composability that you see in like DeFi, you have flexibility, and of course, you get privacy. So you can, for example, just remove the events from the RC20 token. That's private. So because it's all solidity based, to the point, smart contracts in a trust execution environment, you get a very similar. You get a very similar ecosystem. Yeah, sure. So yeah, you deploy smart contracts and the ecosystem evolves. But you can solve some problems in radically different ways compared to how you normally do transparent EVM chain. So you get MEV protection for free. And if you're encrypting all of your core data, nobody can see the content of the transaction when it's being submitted, so nobody can snipe your bids or do sandwich attacks if they don't know what they're doing. But if you do want to take advantage of a confidential EVM, you can make view calls for free. So you don't have to pay gas for them. And you can query the contract and it can execute on its own private internal state and give you results back. So an example of that would be the contract can have a key pair, and you can query the contract and get it to sign stuff for you without paying any gas at all. Or there are also other complications, like if you on Ethereum, you can execute transactions and simulate them from anybody. So you can see what would happen if somebody else executed this. But if you had a confidential contract, you really don't want impersonation. So if you had a password manager, you didn't want somebody to pretend to be you and access your passwords. So we have new problems about authentication and authorization that we don't have with transparent EVM. That once you're in the confidential realm, you have to start thinking about these. And of course, events like with Ethereum, they're public, but you can selectively choose which fields to encrypt. So based on a case-by-case basis, you can have some public information emitted, some private information emitted, and that's entirely up to you to figure out. To figure out what's going on. So we do have a test net. It's up and running. You can go to the documentation and add it to MetaMask. We have a faucet available and an explorer. So because we're a confidential EVM, our block explorer does have a couple of extra bits and pieces. So if you see a green lock icon next to your transaction, that means the core data is encrypted. So just like with SSL, see this transaction is secure. But of course, you can still see who's paying the gas, which contract was interacted with, and where it came from, where it went to. But the core data is encrypted and it's all locked up like that. So the next question is, well, how does this affect solidity? So with the contract state being private and all its runtime state as well being encrypted, and it's not accessible by the node operators, it doesn't give any extra special meaning to the private, internal, or external, public access modifiers in solidity. It just means what they mean. So private variables really are private, and public variables, they're only public because the solidity compiler will auto-generate accessor functions for this. So if you want to have a contract choose what to make public on a case-by-case basis or a person-by-person basis, you need to create a function for that will access its internal private state and then return the value based on if it's authorized or the conditions met. The second bit is transaction encryption. So most wallets don't support this by default. The Ethereum ecosystem isn't set up to be designed with encryption in mind. So what we're doing, we add a little wrapper for the Windows on Ethereum provider. So like SSL, it adds transaction encryption to this. So that means that the RPC server can't see the content, it's encrypted. And you can see the transactions on the block explorer, but again, you can see it's encrypted, so maybe the length of the encrypted data can reveal information about what you're doing. You can also see the gas price, so maybe if there's multiple component parts in the contract, you can infer what the contract's doing based on how much gas it uses. And of course, there are a couple of other bits and pieces to consider if you are trying to achieve anonymity or privacy and confidentiality within this ecosystem. And again, if we're trying to get a contract audited, you have to think of it re-entry bugs, for example, in Ethereum. These are things that we didn't initially think about that came back to haunt us. So there was some thought that goes into how you develop confidential applications on Sapphire. So secondly, the contract code is really public, but if you were to deploy a contract with an encrypted transaction, you wouldn't be able to verify that contract or source file type, source code verification service, because it doesn't know what the contract arguments are to the construction. But if you had a hard code, a password into your contract, that's a bad idea because the contract storage is all there, it's all public. But afterwards, yeah, I mean, this is a so it's funny, it turns out that to take advantage of the private contracts, there's a handful of low-level determinants and built-ins, like a random number generator. So if you have a private contract, you generate cryptographically secure random number generator. You don't need an external VRF service, and that means you have entropy or secret keys that are only known to the contract. And of course, with generating secret keys, you then want some further algorithms. So you can generate a Bitcoin wallet or an Ethereum wallet, and you can start signing transactions from a key pair that's managed by a contract. Of course, we also have encryption and decryption using a misuse-resistant encryption algorithm. So it's a little bit idiosyncratic, and you don't have the same worries about non-streams that you have in other crypto schemes. And then you use that, for example, to encrypt an event that's emitted between you, key that's between you and maybe the regulator, for example, between the participants of the transaction, so only they can decrypt the information. And of course, we've got lots of hashing algorithms, so Amazon, for example, uses B304 because that's certified as being top secret compliant with the US government. And we have support for this, unlike most other people who stick with the ketchup algorithm that is very limited to the Ethereum ecosystem. And likewise, we support the NIST. Swiftly moving on, if you really want to take advantage of the trust execution, can you do things with like few calls? What if you had a contract that executed a bunch of computations and then it signs the results? Then you can take the signed result that the contract gave you and you can pass it back into that contract along with maybe a count that says how many of these operations in a row has it performed. So you can do a trusted execution role where instead of passing all of the data, you just pass the final signature of the computation result. So one of the examples I came up with is if you want to verify all of the Bitcoin block heads, you can submit the validity of the entire blockchain to a single signature. As of this block height, I've verified 40,000 blocks and a certain amount of hash power. And because you can verify that the contract is performing this computation, it's signed the end result of this. And very quickly, the next thing is if both sides of the two chains are both running trust execution, you wouldn't necessarily need bridges anymore. So you can have both sides of the bridge generate key pairs to each other, their key pairs, and then sign messages to each other. You can sign and encrypt messages to each other. So it means a user can carry messages from one chain to another, and it can't be tampered with. There's no need to have like a trust-free layer, separately to a gas grid. And that means you have contracts that securely communicate with each other, and you can have game theoretic incentives and so on to make that communication happen. So yeah, we have a lot of different examples, some startup projects. We've got the Oasis Playground. You can fork these repos. A lot of them have the front end set up, the back end set up, deployments, testnets, and so on and so forth. We have a local Docker image, so the brief files for Sapphire, they're available in testnet, but they're not available in hardhat. So if you look in the documentation, there's the Docker image which has the full logical instance, all the brief files, all the encryption available for you to fully test your apps before deploying. So yeah, that's me, and thank you. Alex,
do you need help? Okay. Just switch the slides. All right. Here we go. So Carrie did a little bit more like a technical detail. This is. I turned that one on. I'm gonna go completely to the other side. Let's see if it's better. Is there a lot of echo or not? It's fine. Okay, perfect. So, Carrie did a little bit more of a technical dive about Sapphire, what it is, and I'm gonna go into a more practical view of it. It's still not loud enough? Okay. Into a more practical view of privacy and use. So, how do we apply what Carrie was talking about in certain use cases? I work in DB, I'm the head of partnerships basically now at Oasis, and for us it's all about the use cases, right? Developers are more excited about the tech, but when we're speaking to projects, we're speaking to apps, they're curious to know how they can apply this and utilize it in their apps, right? So when we're talking about, I get asked a lot about what are the verticals that you're kind of targeting, right? And there's not like one vertical. Matej, can you check? There's a lot of echo. Is it better? Yeah, maybe. Okay. Yeah. So there's a lot of verticals that kind of need privacy. Basically, the whole space in our opinion needs privacy, but some use cases are easier to apply than others, right? So if you look at, where should we apply? Confidential AI is definitely one that's getting a lot of attention now, just with the general interest around AI. Then we have private data management, VAD, secret ballots, for confidential voting, fully confidential NFTs, sealed auctions, where nobody knows how much you're bidding. Games with zero trust assumptions, you can put fog of war on chain, you can have unlockable boxes, all private, with native values on our chain. Private payments is definitely one of them. And I'm going to go through a few that maybe will explain more how this can be applied and maybe, light some light bulbs and give some ideas to you guys what you can create with this. So we start with AI. It's actually, if we look at the AI space now, predominantly it's in the hands of the big corporations, right? You have Meta, you have OpenAI, you have Apple, even Google, right? So I think it's time to think about how to take this back. And we saw the great initiative from Ocean, where they joined forces with Matej and Ajax, to create the super intelligent flights and try to take some of that, control some of that mindshare back and try to decentralize a little bit of things. And see how we can put, all of that back into the hands of the user. And it's difficult to do a lot of things on it because AI. There are certain things that you can do on chain. There is also things that you can maybe do off chain. Yeah, sorry about that, guys. And there's stuff that you can do off chain, but verified on chain, right? And this is what we're working on now. So we have a few projects that are already in the AI space utilizing Sapphire for their needs. But I'm going to talk a little bit more about Ruffle, the runtime off-chain, where what we're trying to do is create a framework where you can have off-chain compute. You can use Google TDX paired with NVIDIA GPUs, right? And then what you do off-chain or offline, or not even offline, off-chain, that you can then attest what you did there, what models you used, all of that, and push that on-chain and have that on-chain verifiability of things with doing stuff in a more, let's say, compute-friendly environment, right? So this is definitely going to be one for, that's going to get a lot of attention and development in the future. This is good for trustless oracles as well, so applications beyond AI. But follow our our socials of Ruffles on the developments on Ruffles, because we see that there's a lot of need and a lot of development interest about this framework. So hopefully we manage to get it out into the hands of the developers soon. Right now we just did the upgrade that enables Ruffle frameworks to be used and compatible with Sapphire, right? But the frameworks, the docs, and all that is getting built very soon. So follow us to get more information on that. But let's go more into the practical use cases of Sapphire, right? So one is compliance for voting. I think that's pretty straightforward, right? The current governance model that we have in crypto is, everyone can see how you voted, and then that can lead to a lot of vote coercion in terms of you are not willing to vote the way you really think, but you just kind of like prefer to vote with the herd. Or there's even, swaying of votes where a large entity can vote first and sway the votes one way or the other. We have also here, I think Apelon is in the Polkadot community, and they have quite a bit of experience with the Open Gov system and how that works, right? So there's a lot of, let's say, on-chain transparent signaling around what certain entities are doing, right? And confidential voting would maybe bring it closer to how we used to vote, where it's like you can truly express yourself without having any backlash from the community, from anybody else, seeing your vote. And with the customizability, you can also set how you want to share the results, right? Maybe just the aggregate, maybe it's who voted but not how they voted, or maybe the owner of the poll or vote wants to know the result but doesn't want to share with everybody else. It's just like a temperature check. So there's a lot of flexibility here, and a lot of interesting stuff that can be done. But we believe this is one of the core things that need to come into the crypto Web3 governance. That will bring a lot of really bad. That's going to really bring a lot easier or better governance into the crypto space. Sealed auctions is also one interesting use case where currently, we remember from the previous cycle where NFTs were very popular, right? And what happened when the new launch of the new popular collection went out? There were gas wars on chain. I think the last major one was the land sale of the apes, right? I think that one actually brought in more in Ethereum fees than actual revenue from the NFTs, right? So how to basically make those auctions still fair and basically eliminate the gas wars, right? If you have sealed auctions, right, nobody knows how much you're bidding. So you have truer price discovery of the items, right? People need to actually need to bid at the value they actually think this item deserves, and at the same time, things can be open for a week, a month, right? There's no gas force. You can decide what's the optimal time you want to bid on the item, right? Or even, I think there's some ideas about sealed auctions of Dutch tokens, where you can have like the Dutch auction, similar to how I think the Fed raises money, where you have a certain amount of tokens you want to sell, and then people can bid on the amount of tokens at the price they're willing to buy, right? And then you get that Dutch auction where you discover what's the actual price that you can sell the batch, right? And get that true price discovery that I think we're missing right about now. If we move forward to the private trading account use case, that's also one that I think can gain a lot of traction. Where we talk about NAV, sandwich attacks, all that, and some say it makes trading more efficient, but it's usually the user that gets the worst price bill, right? So I don't think it's efficient in a way that it kind of levels out across the markets, right? If you have arbitrage, but sandwich attacks, I would say, are a different breed of arbitrage. So if we have private orders, nobody actually sees what your order was before you execute, and then they can actually do own arbitrage after the fact, right? After the order has executed, they can obviously put the price back into balance, right? But they don't need to front run you and then back run the trade to make money off of it, right? So this is one use case that Luminix is solving. This is native private DEX on Sapphire. But there's also a very interesting cross-chain application where, let's say you have synthetics, right? Which is basically, let's say, paper money, right? Where you can have collateral on a home chain. Let's say Arbitrum GMX is very popular, right? So you can keep your users on Arbitrum, you kind of test how much collateral you have there, and then you basically send the attestation over to Sapphire, and then you trade on Sapphire, long, short, whatever, in private. Nobody can punch your orders, right? But at the same time, you do all of that there, And then only when you want to, let's say, withdraw the money or reconcile the books, right, you move back with how much you made there, and then you can withdraw from that pool, from that vault on arbitrum, right? So I think this is actually a quite neat blockchain use case where you don't need to move users or funds over, right? But you just have them utilize Sapphire's privacy for the orders, so they can't get hunted with being everything on chain. But at the same time, they have the same UX as they would trading on Arbitrum directly, right? There's a trick, where you can have users use signatures instead of transactions to execute the orders, and then you have the underlying protocol have a payment contract, right, that does all the fee payments of Sapphire. So I think that's a really neat one that we're exploring with a few teams, and hopefully we're going to have something to show soon. Confidentiality is also one that was more maybe popular in the previous cycle, where it would maybe be needed more in the previous cycle, right? Where I think there was a trend, the right-click save, where people were like, why are you buying the NFTs? I can just right-click save the images, right? Well, maybe, you can have a high-resolution image in the confidential metadata, right? And then you have a low-res in the public metadata, right? And then only the owner is able to have the high-res stuff. Or you have certain features that are only in the private metadata. Let's say if we take like a character within the game, right, that is represented by an MVP, and you do, like those battles, you can maybe have secret traits of that character that are not visible before the battle, right? That can sway one to the other way, right? So it kind of randomizes a little bit the outcome, so it's not so calculated, right? So there's many applications here, and we see it as a very nice use case if NFTs are coming back, right? And I think they will. I think there's potentially less interest now, but NFTs definitely, I think, are coming back, and maybe in a different shape or form. Maybe you're going to be attaching NFTs to real-world assets, right? And then the real-world assets will need some private metadata there as well. So another use case that we see a lot of attention. Obviously, gaming is probably the most obvious, but at the same time quite hard to apply, right? Because current Web3 games usually rely on a lot of off-chain logic, right? So the game developers are very focused on just the development of the game, making a good experience, making it interesting, and nobody can resent them that, right? But at the same time, because they have the off-chain components, what they do currently is they just use the off-chain side of the game to store anything that needs to be stored private, right? So they can be easy way out, right? And we believe here that if we want to have true crypto-native, games, there's going to be a need to have everything on-chain, at least to a certain extent when it comes to verifiability. If we look at, gambling, for instance, right? Having that verifiability that the decks are not, modified, or rigged, that you're getting true randomness with the cards. I know there's a lot of protocols that can verify that, right? But if you can have like just native on-chain confirmation of that, it just makes it easier, right? So definitely gaming is one use case that we are exploring, but it's slightly more difficult to apply, I'd say. And we're coming to a very interesting one that I'm very excited about, and that's the Oasis account abstraction. So the way the majority knows account abstraction is the 457 EIP, and there are some new versions now that kind of change it here. But if we go to the 457 one, it's more about who's paying for gas, right? And you need to deploy the contract on the chain where you're interacting with it. The Oasis account abstraction is slightly different because we have that unique capability of storing secrets on chain, right? If you don't have privacy, right, on-chain privacy, you can't do that. And what this brings is that you can have private keys of 0x wallets, of Bitcoin wallets, Polkadot wallets, you can actually store them on-chain and then tie that private key to a different authentication method, such as biometrics, passkeys, username, password if you want, right? And then that's your signing method for that private key. a few days back we were discussing how to call this, right? And there was a good proposal, potentially a software ledger, right? It's not a hardware wallet, but it's a software wallet that's still non-custodial, secure, right? It's not a completely hot wallet, right? Because private key is in a secure play on Sapphire, but at the same time, it is a software-based wallet, right? Here, yeah, I'm going to invite Daniel to come on to show us more. So Apollon is actually building out a product using Oasis to store private keys and then, utilizing different authentication methods to authenticate, to sign, to send transactions. And yeah, Daniel, let me finish up and you go. Thank you. Any questions? Potentially. No? We're good, okay. Find me in the back if there's anything. Okay. Hi everyone. Yeah. Okay. Yeah, sure. We're gonna have a 1 minute break here. Hi. Commercial break.
Commercial break.